Hi everybody! In this video we're going to take a look at some sample screen materials and talk about the different qualities to look for. And we'll look at some lights and see how they behave on screen. We'll take a silhouette, put it in between the two, and voila, shadows. Let's get started. This shadow puppet is made out of cardstock. And you can see on this polypropylene screen that it appears opaque when it's backlit. This is the same puppet behind a paper screen made from lining stock for problem walls. It's a heavy paper, nice texture to it. And you can see it's a bit more translucent than the plastic. And this is the same puppet behind a piece of frosted Lexan, which is definitely too transparent to use as a screen. It might be great to paint for parts of translucent puppets. Here's a piece of untreated muslin. Because it's an open weave, muslin generally has to be sized in order to prevent seeing the light source through the pores of the fabric. This view is from the same side as the light source. And if we put something underneath of it, right up against it, like this card that says test, you can see that you can see through it, but it's not transparent, it's translucent. If it was opaque, we wouldn't be able to see the word. And if it was transparent, we would see too much, like with this piece of frosted shower curtain. Generally, if something is just frosted, it's going to be more transparent than translucent. So you can see it's better to go for materials that look more white than frosted. And before you go and buy a big piece of something, you can do a quick test by putting your hand under it, maybe even taking some print material that's on opaque stock, and put it underneath and see if you can see the letters through it. If you can't, it's opaque. If you can see too much, it might be too transparent. And so that way you can do a quick test before you make a purchase of something. White shower curtain liners are easy to find and pass this test, but frosted shower curtains do not. The downfall of shower curtains is that it's really difficult to get rid of the wrinkles. It's not impossible, but it's difficult. Check on the web, Google it, and definitely stretch it. This is a freestanding PVC screen that is covered in Lycra. I've used this for workshops in schools because it pops apart really easily, and it was also used for some shadow film work. The good thing about it is the stretchable nature is really fun to experiment with. The bad thing about it is that the light source is really visible. So that means you just need to get it at an angle where the light is neither in the audience's eyes or pointed directly at the camera if you're using it for film work. And that's where masking comes into play, because if you're going to have to move your light source either below or above your screen to keep it angled so that it's not directly in anyone's eyes or in the eyes of the camera, then you have to mask that area because it's either going to appear above or below. In addition to that, there's a sheen to the fabric, which can be a problem in front of an audience as well. And my understanding is that tricot has less sheen, so if you want to experiment with something that has stretch to it, I would suggest trying some tricot. So I've talked about seeing the light source through the screen, and I know that the pictures that I've showed you don't really show the light in them. It looks more like a hot spot. So a hot spot is a concentrated area of light rather than the whole screen having kind of a similar appearance when the light is well diffused. A hot spot has a concentration. And that's what these photos look like that we just went over. But in person, you can literally see the light source. That can be dangerous, especially if you're dealing with a high-powered light source. I don't expect that you guys will necessarily have anything that high-powered, but when you start to work with halogens, if somebody can really see the light source, and if they were to stare at it, which I doubt they would because it's very uncomfortable, it can be a problem. So you need to be able to discern the difference between seeing the light source and having a hot spot, and you want to note those things in your materials trials report. And I'm going to go over some more examples of lights behind a specific screen and try and describe those differences to you. But just keep that in mind. A hot spot is a high concentration. Seeing the light is something else entirely. Seeing the light source is generally unacceptable. A hot spot might be acceptable if it's not distracting. And as I described, you can often move the light, the position of the light, to try and avoid that. Now let's talk lighting, lamps and instruments. Well, you might think that that's a standard household light bulb on the left, and you'd be right. If you're talking to a stage lighting crew or electrics person, they're going to say that's not a bulb. A bulb goes in the ground. That is a lamp. All of these are lamps. They're all incandescent lamps. So the first one, yes, a standard white household lamp. And you can use that. It works fine for direct screen puppetry. Direct screen meaning that the puppet is held directly against the screen. In fact, all of these except for one are going to be used only in that way. Why? Because the light is diffuse, it has a long filament inside there, inside of the lamp, and as soon as you pull the puppet away from the screen, it's going to get blurry. The second one is obviously clear, and the next one, while it looks just like the second one, the third one is actually a halogen. That lamp is problematic. It has a lot of stuff going on inside, and you're going to see that it shows up on screen. Floodlights work pretty well, and all four of these, as I said, serve as diffuse or filiform lamp, and they're great for directly on-screen work. The wattage, as well as whether or not you choose clear or white, is going to depend on your screen material and the size of your screen. What I don't have an example of here is a fluorescent light, but it behaves in the same way as these first four incandescents. That's because the light is coming from many different angles and not just one concentrated source. The last one on the right, the little tiny one, is a halogen lamp. The size of the filament is what sets it apart from all the rest of these incandescents. Punctiform bulbs, or bulbs with short filaments, allow you to have a greater depth of field between the light source and the screen, so that your puppet can move away from the screen and actually change in dimensions. The closer it gets to the light source, the larger it will get. Now there will be some limitations. You'll have some fuzziness at some point, and that point will be determined by the lamp itself and the distance from the screen and the puppet. This particular lamp doesn't perform well head-on, in other words, with that little point pointing towards the screen, like it would be positioned in this instrument, because it'll cause this kind of distortion on screen. It's better to use it on its edge in an instrument like this one. This lamp in this particular fixture gave really great diffusion. I got light all the way across the screen at a very close distance, only 15 inches or so. That hot spot that you see in the center is a little bit troubling, especially on video. Not so much in person, but if I was going to use it, say, for a video in this class, it is problematic. So I went ahead and blacked out the reflector to see what that would do to fix the problem. One way to do that is just cover the small holes where the lamp is inserted with a little bit of tape, and then spray the reflector with high heat spray paint. There's another way to mask out a reflector, and I'll show you that when we get to the LEDs. Here's a side-by-side comparison of the light output of this same instrument, same lamp, just having the reflector blacked out. So obviously we don't have as much light output. We don't have the hot spot. The rod is much more visible in the image on the right with the blacked out reflector because we don't have light coming from many different points on the dome of the instrument. We really have narrowed it down just to that short filament. So there are trade-offs when you black out a reflector. Obviously the spray paint is a permanent way of doing this, and the other method I'll show you later is not permanent. One of the disadvantages of working with halogens is that they burn really hot. That's why the high heat paint. So you have to take precautions backstage when dealing with them. I was once on a show that used a halogen in a dimmer, and the last person who used it didn't turn the dimmer all the way off. The lamp was left to burn, and before you know it, we were smelling smoke. So you have to have a safe place to put them. You need to be certain that they're off when they're supposed to be off, and never handle them with your fingers, with your bare fingers. You want to take a tissue or some kind of paper or paper towel, obviously once they're cool, if you need to change that lamp out. The oils from your fingers will transfer to the lamp, and then that will burn and shorten the life of your lamp. And what you see in the upper right corner in this photo is an adapter, and it allows you to use this G9 base halogen in a standard socket, or an E26. That's our standard household lamp socket. Halogens come in many different shapes and size bases, so before you buy an adapter, you want to make sure that you're finding one that's going to suit the particular lamp that you have. In addition to that, you need to make sure that you have an instrument that can handle that high intensity heat. Larry Reed's company, Shadowlight Productions, deals with the high intensity of these lamps by building them into junction boxes and frying pans. Similar to the short filament halogens, single LEDs will also give you a long depth of field to play in. This first one on the left is an IKEA lamp. I've seen it all over the place with puppeteers. It's really flexible, gives great output. It works so well because it's a really tiny LED. It's hard to measure how big it is because it has a lens on it. This zoomable LED flashlight also has a focusing lens on it. Lenses are fine, but reflectors are not if you're looking for this increased depth of field effect. This LED flashlight had a reflector on it, and I went ahead and blacked it out using Roscoe's black wrap. This is a cinefoil. It's like aluminum foil, but it's heavier and it's coated with high heat black matte coating. When you're looking for an LED flashlight, try and find one that doesn't have multiple functions. Sometimes they'll be low, medium, high, strobe. It's a recipe for disaster when you're performing in a show. Better to just have a simple on-off, possibly a zoom. This guy said, you just pull it out. Some of them rotate to zoom. And if you can find one that has a dimmer function, that's even better. What's cool about LED flashlights is that you can now move the light as well as the puppet. That's what's happening in this video. It's only the light that is moving in and out, around and around. The puppet is stationary. Now, you can see a strobe effect here, but in person, that strobe is not visible to the human eye. So obviously this would not be a good choice for on-camera work, but it works great in a theater. This was built by a friend of mine, an electronics wizard, and if you have such a friend, ask them to build you a dimmable LED flashlight. The final LED lamp I want to share with you is this one. It's called a PAR, which is a misnomer because a PAR is really a parabolic aluminized reflector. This is really just an LED flood. I took the lens off the front of this lamp because it changed the nature of the single LED. A couple of nice things about this. First, it's made to go into a standard household socket, so it's simple to install on a utility light like this one. In use, that yellow area was more diffuse and less distinct than what you're seeing in this photo, and to me it seemed more just like some brightness than really a true hotspot. Here's that same LED flood inside of a blacked out reflector. Really makes a difference on that hot spot. Also makes a difference in how much spread we get from the light. And here you can see that same LED flood in the same blacked out instrument, but using it with a paper screen. Now we totally lose that yellow that yellow look of the LED, the diode itself, using the paper screen as compared to the polypropylene screen. Because the diode itself is much larger than, say, in the IKEA lamp, you're not going to get as close to it as you would with the smaller diodes. But this lamp has a huge spread, 18 feet at a 4-foot distance. So if you were to use it in larger format work, you would have a lot more room to play, and you wouldn't need to get within 16 inches of the lamp. In general, you'll find that tungsten and halogen incandescents are much warmer than LEDs in color temperature, and LEDs are cooler to the touch. And longer filaments, or reflectors that scatter the rays of light, are going to diffuse the image more so than a small point source, a punctiform light source, which is going to sharpen the image, especially through the larger depth of field. Therefore, rods are much more visible with punctiform sources and much more difficult to hide. Finally, I want to show you an image from an overhead projector used as the light source. This is not with the puppet on the platen. This is using it as a direct screen light source. You would focus the projector, whether it was an overhead projector or a slide projector or even a movie projector, focus it onto the screen and use your puppet directly on screen. You will get a little bit of play area where you can pull back away from the screen, not as much as with a punctiform source, but more so than with, say an incandescent or regular incandescent lamp. The downside of using an overhead projector or a slide projector or such can be the noise from the fan, so that's something to be aware of. So, as you can see, there's a lot to explore with screen materials and light sources. As you're embarking on your explorations, please be sure to check out the safety ratings of your lighting instruments and stay within them. Also, keep in mind that you won't need a punctiform light source until Module 6 or 7. So do some exploration now, and then put them aside and use your filiform light sources as we explore the world traditions ahead. For now, take this time to do the exploration so that you know what your tools can do for you, and then later you can bend the rules. Maybe it's okay for something to be fuzzy around the edges. See you soon.